Hello all, welcome to GNB classes. In this class we are going to discuss about the number of even and odd divisors, number of divisors of the form 4n plus 2, number of divisors which are perfect square, number of ways in which n can be resolved as a product of two factors, number of ways in which n can be resolved into two factors which are relatively prime, sum of the divisors of n, sum of the kth power of the divisors of n. To understand this class better, you must see my first class on permutation and combination. Those who have not seen, link has been given in the description. So please see that video first and then come for this second class where you will understand much better. Here I have written the prime factorization of 12 and its factors or divisors, and the prime factorization of 60 and its respective divisors or factors. Now let us try to bring some twist in the problem. Now we already know how to find out the number of divisors of any natural number. I have shown it in my first class. But now my question is how to find out the number of even divisors and how many number of odd divisors of any natural number. Okay, how to find out number of even divisors, number of odd divisors. The natural number 12. What are the even divisors? 2, 4, 6 and 12. So even divisors means that divisors which are divisible by 2. That is, in the factors, 2 should be one of its factor. It has to be with the other numbers or without the other numbers, but 2 has to be there. That is, 2 into 1 accepted, 2 into 2 accepted, 2 into 3 accepted, or 2 into 6 accepted. So every time we are having 2 as one of its factor of that divisors. Okay? Now how to say it mathematically? In the first set, we are having for this 12, 2 to the power 0, 2 to the power 1, 2 square. And the other numbers for 3 in the second set is 3 to the power 0 and 3 to the power 1. But here we will reject 2 to the power 0. We will not consider 2 to the power 0 as one factor while calculating its divisor. Because if 2 to the power 0 is there, then there will be no factor 2 in that divisor. Okay? So in that case we will find out that if we choose any number from this set and any one number from this set, it will give you a divisor which is an even one. Is it clear? So from here we are having 2 elements, from here we are having 2 elements, therefore 4 number of even divisors are there. Is it clear or not? Suppose if I say that any natural number is, suppose this is the natural number which I have expressed in prime factorization, where P1, P2, Pn are distinct primes and K1, K2 till Kn, they are the whole numbers. In that case, if you find that P1 is 2, then total number of even divisors will be equals to K1. Why I am taking K1? Because I am rejecting 2 to the power 0 from that set. And the other numbers you can take any one from the other primes, that is the total number of elements in that set will be K2 plus 1, K3 plus 1 and so on till Kn plus 1. Is it clear? It is the total number of even divisors of that natural number n. The only thing is that if 2 is one of the primes present in the prime factorization of that natural number n. But suppose if there is no 2, if there is no 2 in the prime factorization, then total number of even divisors will be nothing but 0. Tell me yes or no. Because if I don't get 2 as one of my number in the divisors, you will not get the divisors which are even. Let us take an example like, say 45. 45 can be written as what? 3 square into 5. Okay? Now here you will not get any factor which is an even divisor of 45. You calculate, you will find no even divisors of 45 because there is no 2 present in the prime factorization. Is it clear or not? Absolutely. Okay. Now let us come for number of odd divisors. Look it carefully. Here the odd divisors are 1, 3, that's all. Only 2. Now there are 2 ways of doing this. First, you find out the total number of divisors. Then you subtract the total number of even divisors, which will give you the odd divisors, because divisors can be either even or odd. So if you can find out total divisors and you subtract even number of divisors, then we will get odd number of divisors. So total number of odd divisors equals to total number of divisors minus total number of even divisors. Yes or no? This is one way of doing the sum, but indirectly. So directly if we want to do, tell me the logic. Odd divisors means there should not be any factor which is divisible by 2. So if at all 2 is present in the prime factorization, if at all 2 is present in prime factorization, we will not consider any of 2's in our calculation of number of odd divisors. As simple as that. Getting my point? Let us consider the case 60 here. Here the odd divisors are what? 1, 3, 5. That's all. 3 only odd divisors are there, right? So in this case, the prime factorization is something like this. Yes or no? We have another odd divisor, sorry, it is 15. Okay. So now in this case, you see, there is 2 as one of the primes present in the prime factorization of 60. So to find out the number of odd divisors, what I will do, I will simply reject this. Because any number which is considered 2 with it will not be an odd divisors. Okay, so in that case, what we will do, we will consider 2 cases. One is 3 to the power 1, 3 to the power 0 and 3 to the power 1, 5 to the power 0 and 5 to the power 1, correct? And here there will be only one element which is 2 to the power 0. Because 2 to the power 0 is 1, it means there is no 2 in the factors. So in that case, how many number of odd divisors we will get? From here it is 1, 2 and 2. Answer is 4. That exactly what we got. Yes, same thing in case of 12 also. It's 2 square into 3. So since there is 2 in the prime factorization, so we will reject this. So in the first set, we will only consider the element 2 to the power 0. And in the second set, we will consider the elements 3 to the power 0 and 3 to the power 1. So there will be 2 odd divisors. Yes or no? One is 2 to the power 0 into 3 to the power 0. Another one is 2 to the power 0 into 3 to the power 1. Same thing we are getting here also, that we are having only 2 odd divisors which we can see from its divisors of 12. Right? So how to generate a formula? When we find that in the prime factorization of any natural number, there is 2. If there is 2, we will simply, if say P1 is 2, then we will simply reject that part. And what we will do, total number of divisors will be total number of divisors. Divisors means it's odd divisors. Will be what? It will be nothing but K2 plus 1, K3 plus 1 and so on, Kn plus 1. That's it. And say in the prime factorization there is no 2. That is, P1 is not equals to 2. In that case, total number of divisors, again, the divisors are odd, will be equals to 2 is not present. That is, P1 is another prime. So its exponent k1 will be considered in the calculation. So it will be k1 plus 1, k2 plus 1 and so on till kn plus 1. Is it clear? So have you understood the total number of divisors which are even as well as how to find out the total number of divisors which are odd? Okay. Now let us give a little twist in it. How many number of factors are there in say 60? 60 means it's 2 square into 3 into 5. How many number of factors are there in 60 which is of the form 4n plus 2? Okay. Now if we observe, we will find that 4n plus 2 is basically what? If I take 2 common, it is 2n plus 1. That is, to find out the factors or the divisors which is of the form 4n plus 2, 1, 2 must present in that factor. In 60 prime factorization, we are having 2 2's. It doesn't matter. Whether we have 2 2's or 200 2's, it doesn't matter. We will only consider 1 2. Only 1 2 we will consider to get the divisor of the form 4n plus 2. The other factors can come in different forms, that is 3 to the power 0, 3 to the power 1 for the prime 3, and for prime 5 it will be 5 to the power 0 or 5 to the power 1, doesn't matter, but only 1 2 will be considered in those cases, right? Therefore the total number of divisors which is of the form 4n plus 2 will be 1 into 2 into 2, that gives us only 4. Therefore 4 is the total number of divisors which is of the form 4n plus 2 for the natural number 60, and that we can see it easily. What are the factors of 60? So in that case you will find 4n plus 2. What is n? N is any whole number. Okay, n is any whole number. Now of the form 4n plus 2, it can be if n is 0, we are getting the factor as 2. If n is 1, we are getting the factor as 6. If n is 2, we are getting the factor as 10. If n is 3, we are getting the factor as 14, but there is no 14 factor over there, so forget it. If n is 4, no such factors we are getting. If n is 5, no. If n is 6, no. If n is 7, yes, we are getting here. If n is 7, the factor is 30. No more factors we will get. So we are getting the factors as 2, 6, 10 and 30. That is, there are 4 such divisors which is of the form 4n plus 2. That's exactly what we got from the calculation itself. Is it fine? Absolutely. Okay. Now let us say how many number of factors are there in 60, which is 2 square into 3 into 5, which are perfect square, which are perfect square. Okay. Now to find out any divisor which is a perfect square, we must understand one fact, that is, whichever prime present in the divisor or factor, it must come with an even power. If 2 at all comes in that factor which is a perfect square, either it will be, in this case, either it will be 2 to the power 0 or it will be 2 square, or it can be 2 to the power 4, but there is no scope of taking 2 to the power 4 in this factor. So the only factors that can come is either 2 to the power 0 or 2 square in this case. 3 will not come because 3 cannot come with an even power, as there is no exponent other than 1, as well as 5. Now suppose, let us say, we have taken a number, some number, say after prime factorization we are getting something like 2 to the power 4, 3 to the power 5, and say 5 to the power, say 7. Now if I ask you this, how many number of divisors of this natural number you will get which are perfect square? So one thing for sure, that whichever number will come, it must come with an even power of that prime. So for 2 to the power 4 in that set, we will either get 2 to the power 0 or 2 square or 2 to the power 4. From 3 to the power 5, we will get 3 to the power 0 or 3 square or 3 to the power 4. For 5 to the power 7, we will get 5 to the power 0, 5 square, 5 to the power 4 or 5 to the power 6. That's it. So any of this number comes, it is always a perfect square. So total number of perfect square divisors possible is 3. Any one you choose from this set, the total number is 3. From here again it is 3. From here again it is 4. So total number of divisors which are perfect square for this natural number will be 36. Is it clear? And for this one, what will happen? Think about it. For this one, what will happen? Here, only 2 square and 2 to the power 0 will be considered. That is, there are 2 such numbers in the divisor set of 60 which are perfect square. Yes or no? Now, if we just expand it, we will find the divisors. If we find out, so out of that, you can easily see that the perfect square, the divisors which are perfect square, is only 1 and 4. There are no such divisors which are perfect square in the divisor set of 60. Is it clear? So have you got it? So what is the basic conception? That whenever they ask you to find out the perfect square divisors, you will always say that the divisors will be a perfect square when it comes with an even power. Okay? If it doesn't come with an even power, it will not make a divisor which is a perfect square. Now let us find how many ways are there where n can be resolved as product of 2 numbers. Now again we will use those 3 things that we have already considered in the beginning of our class. 3 numbers, that is 12, which is 2 square into 3, 60, which is 2 square into 3 into 5, and 36, which is 2 square into 3 square. Now the total number of divisors of 12 is nothing but 2 plus 1 into 1 plus 1, that gives us 6. 6 is the total number of divisors of 12. What about 60? It is 2 plus 1, 1 plus 1, 1 plus 1, that is 12. Is it clear? And what about 36? It is 2 plus 1 into 2 plus 1. So 9. So from here we can observe one thing, that the total number of divisors of any natural number which is not a perfect square is always even. And the natural number which is a perfect square, the number of divisors is always odd. This you must keep in your mind. Now, if I go for 12, what are the factors? What are the divisors? So how many number of ways are there where this 12 can be expressed as a product of 2 numbers? 1 12, 2 6, and 3 4. Correct? So there are 3 ways of resolving 12 as a product of 2 factors. Same thing with 60. You are going to have the divisors of 60s are so the total number of ways where the 60 can be resolved as a product of 2 numbers are 160, 230, 320, 415, 512, 6 and 10. Right? So here we are getting, there are 6 ways of resolving 60 as a product of 2 numbers, and we are getting 3 ways of resolving 12 into product of 2 numbers. So how we are getting, when n is not a perfect square, we are getting the total number of ways when n can be resolved as a product of 2 numbers as number of divisors divided by 2. That's it. Okay? But this is not true for when the number is a perfect square. Otherwise, in that case, it would have been, the total number of divisors of 36 is 9, then it would have been 9 by 2, which is 4.5. which is not possible because 4.5 is not the number of ways where n can be resolved as a product of two numbers. It cannot be a fraction. So what we do when we find that the natural number n is a perfect square, all we do is when n is perfect square, we calculate it in this way. Number of divisors plus 1 divided by 2 is the total number of ways in which the number which is a perfect square can be resolved as a product of two numbers. Let us just check it. What are the divisors of 36 there? I'm sorry, 9 is there. 9, then 12, 18 and 36. Okay. So here, if I go for resolving as a product of two numbers, we will find that we are getting 136, 218, 312, 49, and we are getting 66. Is it clear? So have you observed this thing? In every term, there is no digit which is repeated. This is the only case where the two digits are identical. And that is the difference. That makes all the difference when the number is a perfect square. So here, how many number of ways are there where 36 can be resolved as a product of two numbers? There are 5. So how you are getting? We are simply dividing. Here the total number of divisors are 9. So it is 9 plus 1 divided by 2, which gives us 5. And that exactly 5 ways we got where 36 can be expressed as a product of two numbers. Is it clear? So what we have learned? We have learned that when n is not a perfect square, the number of ways in which n can be resolved as a product of two numbers is number of divisors divided by 2. And when n is a perfect square, the number of ways in which n can be resolved as a product of two numbers is number of divisors plus 1 divided by 2. Is it clear? Now sometimes question can come, how many number of ways in which n can be resolved as a product of two numbers when the numbers are distinct? You see, numbers are identical. That occurs only when it is a perfect square. Otherwise, in normal case, when the natural number is not a perfect square, this identical number will not occur as a product of two numbers to represent that natural number. Is it clear? So when the question is, how many number of ways are there in which the two numbers are distinct? In that case, if you observe 36, we are going to get only 4 numbers. These are the 4 ways, I should say, in which 36 can be expressed as a product of two numbers in which no digits are repeated. So in that case, you will say that the total number of ways are number of divisors minus 1 divided by 2. This is the total number of ways in which a natural number n can be expressed as a product of two numbers when no digits are repeated. And that is only possible when the number is a square one. Is it clear? Absolutely clear? Okay. Now let us bring some more twist in the problem. Let us say how many number of ways you can express n as a product of two numbers which are relatively prime to each other. Relatively prime to each other means the numbers that you are going to select to represent n as a product of two numbers will be co-prime to each other. Is it clear? Let us take the example 12. As a product of two numbers, if you want to express 12, what are those? Okay. Now, how many numbers, this ordered pair you can select which are relatively prime to each other? Relatively prime means the GCD of those two numbers will be equals to 1. We can see easily that GCD of 1 and 12 is 1 and GCD of 3 and 4 is 1. So this and this one, these two are the ordered pairs where the numbers are relatively prime to each other. So how many number of factors are there which are co-prime to each other in this case? In the case of 12, there are only 2. Let us consider 60. And the ordered pair in which the 60 can be represented as a product of these two numbers, those pairs are and out of this we have to consider how many number of pairs are relatively prime to each other. Okay? 160 they are relatively prime to each other. 230 no. 320 yes. 415 yes. 512 yes. But 610 no. Okay? Because the GCD of 6 and 10 is 2. So there are 4 such pairs in which this 60 can be expressed as a product of these two numbers, in which these two numbers are co-prime to each other. So here the total number is 4. Okay. Now let us just do the last one, which is your 36. In that case, what are the pairs which when multiplied gives you 36? There. Okay. Now out of this, which pair is relatively prime to each other? Here 1 and 36 they are relatively prime. Here 6, 6 is the only group where the digits are repeated. It happens only in case of a perfect square. Now 6, 6 are not relatively prime. So the only set which are relatively prime to each other other than 1, 36 is only 4, 9. Neither 2, 18 nor 3, 12 are relatively prime to each other. Is it clear? Okay. So in this case, the total number of factors which are co-prime to each other is 2. Now how we are getting this? If we observe, we will find that 12 is written as 2 square into 3. So how many number of distinct primes are there in prime factorization of 12? There are 2. And we got total number of ways in which 12 can be expressed as a product of two numbers which are relatively prime to each other are 2. So how we are getting this? This is simple. 2 to the power 2 distinct primes are there. So you just do 2 to the power 2 minus 1. That gives us 2. For this one, 60 can be written as what? 2 square into 3 into 5. So there are 3 distinct primes. So the required number will be 2 to the power 3 minus 1, that is 2 square, which is 4. That's exactly what we got. Okay? And for 36, which is 2 square into 3 square. So we are having 2 distinct primes. So the total number of ways in which it can be expressed as a product of two numbers which are relatively prime to each other will be 2 to the power 2 minus 1, that is 2. So what formula we can establish is that when n is expressed as a product of primes, and if there are n distinct primes, then the total number of ways in which n can be expressed as a product of two numbers which are co-prime to each other or relatively prime to each other will be 2 to the power n minus 1. Okay? What is n? Again I am mentioning here n is nothing but the number of distinct primes. Okay? Now we will learn how to find out sum of all the divisors of any natural number n. Let us take the example of 12. 12 in its prime factorization will be 2 square into 3. So what are the divisors? Let me just draw that two sets. One consists of 2 to the power 0, 2 to the power 1, 2 square. The another set consists of 3 to the power 0 and 3 to the power 1. Therefore, the divisors are so these are the 6 divisors of the number 12. Now, I want to add up all those divisors. So what will be the result? How we get it? Now you see, we can easily calculate this thing and we can write it here. But that is not the wise way of doing the sum, because ultimately we want to establish a formula which will help us to find out the sum of all the divisors of very big natural number. So in that case, what I am doing here, I am just manipulating some way which will give you something like this. If I take 2 to the power 0 common from here, we are having 3 to the power 0 plus 3 to the power 1. If I take 2 to the power 1 common from this 2, we are having 3 to the power 0 plus 3 to the power 1, and 2 square common from this, so we are having 3 to the power 0 again plus 3 to the power 1. Now if I take 3 to the power 0 plus 3 to the power 1 common, so we are left with 2 to the power 0 plus 2 to the power 1 plus 2 square. Therefore, the answer will be 2 to the power 0 plus 2 to the power 1 plus 2 square. We can directly calculate this. Again, I'm telling you, my motto is not to just find out the answer for this question. My motto is to establish a formula. So here I will apply my GP summation formula. In that case, what you will write? You will write the common ratio is 2 and the first term is 1. So the summation will be 2 to the power 3 minus 1 divided by 2 minus 1 into, for this one, it will be 3 to the power 2 minus 1 divided by 3 minus 1. Tell me yes or no, because here the common ratio is 3. Therefore, the answer will be, we can calculate it easily, it will be, it's 28. Okay. Now, please observe this thing, because this will be needed to establish the formula. Okay, now let us take another example of 60. What is the prime factorization? It is 2 square into 3 into 5. Let me again draw 3 sets. So these are all the factors or the divisors of the natural number 60. Now we want to add this. That is, we are adding all the divisors. So what we are going to have? So look it carefully now. If I take 3 to the power 0 into 5 to the power 0 common from these 3 terms, we are having, again we are taking 3 to the power 0 into 5 to the power 1 common from this term. So we are having, again we are taking 3 to the power 1 into 5 to the power 0 common from these 3. So we are having, and again we are taking 3 to the power 1 into 5 to the power 1 common from these 3 terms, these 3 divisors. So we are left with, okay. Now if I take 2 to the power 0 plus 2 to the power 1 plus 2 square common, so we are left with, now let me take common 3 to the power 0 from this 2 and 3 to the power 1 from here, so we are left with this one. So now it can be written as 3 to the power 0 plus 3 to the power 1 into 5 to the power 0 plus 5 to the power 1. Observe it carefully. Okay, so what will be the sum? The sum will be again applying the GP series. So we are getting the answer like it's coming to 168. Is it clear? Now let us try to generate a formula which will help us to find out sum of all the divisors of any natural number which are having a very large value. Okay? So if we observe here for the first case when we have considered 12, in that case what we have done, the prime factorization was 2 square into 3. So my final answer that I have written in this form is like, you see, here the power is 2. So I've written it is 2 cube, that is 2 plus 1 minus 1, then 2 minus 1, into the prime is 3 and the power is 1, the exponent is 1. In that case I've written 3 square, that is 3 to the power 1 plus 1 minus 1 by 3 minus 1. Is it clear? See this one, what we have done. Here the exponent of 2 is 2, so I have used here, we got here, it is 2 to the power 3, that is 2 plus 1. Same thing with 3. Here the exponent is 1 and I have written here as 1 plus 1. Similarly for 5, it is 1 plus 1. So what actually we are getting out of it? We can write, look it carefully. Suppose if n is then sum of the divisors of this natural number n will be nothing but p1, the first prime, to the power k plus 1 minus 1 divided by p1 minus 1. That exactly what you have done here as well as here. Yes or no? Then into p2 to the power k2 plus 1 minus 1 by p2 minus 1, and this thing goes on. And the last will be pn to the power kn plus 1 minus 1 divided by pn minus 1. Tell me yes or no. So this is the formula that we will use to find out the sum of all the divisors of the natural number n. Is it clear? Now I can give a little twist in this problem in this way. Now the little twist is that if I ask you what is the sum of the kth power of the divisors, that is sum of the kth power of the divisors. Okay? So in that case what will happen? Kth power of the divisors means you are actually finding out these divisors but with the kth power. Right? Now let us see what are the changes that will occur. For the first one, here I am writing, it will be again 2 to the power 0, 3 to the power 0. In this case, it will be 2 to the power 0 into 3 to the power k. In this one, we will have 2 to the power k into 3 to the power 0. For this one, we will have 2 to the power k into 3 to the power k. For this one, we will have 2 to the power 2k into 3 to the power 0 plus for this one, it will be 2 to the power 2k into 3 to the power k. Okay. Now, if I take 2 to the power 0 common from these two factors, so we are having 3 to the power 0 plus 3 to the power k. From here, if I take 2 to the power k common, it is 3 to the power 0 plus 3 to the power k. And from this, if I take 2 to the power 2k common, we are left with 3 to the power 0 plus 3 to the power k. Yes or no? Now you see, can you find out the difference between this and this? Think about it. So it is 2 to the power 0 plus 2 to the power k plus 2 to the power 2k into 3 to the power 0 plus 3 to the power k. See the difference between this expression and this expression. Everything is same, only the exponent has been multiplied with k. Okay? So for this one, the summation will be, this is again a GP series whose first term is 1 and the common ratio is 2 to the power k. So it will be 2 to the power k into 2 plus 1 minus 1 by 2 to the power k minus 1 into 3 to the power k into 1 plus 1 minus 1 by 3 to the power k minus 1. It's all same. Only the exponent is multiplied with k. So can we generalize this formula? When they will ask you to find out the sum of the kth power of the divisors, then everything will remain same over here. Only the exponents will be multiplied with k. Therefore, sum of the kth power of the divisors, the general formula I'm writing, will be what? This general formula I'm writing here, it will be p1 to the power k times k1 plus 1 minus 1 by p1 to the power k minus 1 into p2k k2 plus 1 minus 1 by p2 to the power k minus 1, and this thing goes on pn to the power k into kn plus 1 minus 1 divided by pn to the power k minus 1. Tell me yes or no. So this is the sum of the kth powers of the divisors. Is it clear? If you like my class, do hit the like button and subscribe. Click the bell icon to get notified about my new uploaded videos. Put your queries and doubts in the comment section. You can now reach out to me at my mail, my Facebook page, my Instagram. You can also join my WhatsApp group for doubt clearing. Link given in the description. See you in my next video. Till then, goodbye and take care.